Hello students, the question here says a uniform chain of mass m and length L overhangs a table with its 2/3 part on the table. Find the work to be done by a person to put the hanging part back on the table. So, since nothing else is mentioned about how the chain is being pulled up on the table, we can assume a few things here. And one of those things would be that, let's say the person is pulling the chain like this with a force F. To pull the chain, pull the hanging portion of the chain on the table, he is pulling it like this. And we can assume here, because again we have no information, no other information about if the chain gains some velocity in the process of moving. We have to assume that this force, external force applied by the person, is just sufficient to balance the weight of this hanging portion of the chain, so that he is able to just pull the chain up without giving any additional velocity to the chain, without doing any additional work. The work done by the person at any point in time will be just equal and opposite to the work done by gravity on this hanging portion, so as to keep the chain move up slowly and steadily. Okay. So, at any point in time, this force F applied by the person will be equal to the portion of the chain hanging down here. And that brings us to the case where we have to find out the small work done, differential work done, because this force will change with time, because as more and more amount of chain will go up on the table, lesser part of it will be hanging, and hence the weight of that hanging portion will become less and less. So, the external force to be applied should also decrease with time, right? So, in order to do this question, we will take an intermediate state. Let us draw the figure once again, and let us take a state where, let's say, it is some part of the chain has already been taken up, and it is now x length of the chain which is now hanging. Okay, so that L minus x is already up on the table. Now, x can take any value, we will put the limits of x a little later. For now, do we understand that the length of the chain hanging, if it is x, we can find out the mass of the hanging portion. If we call it m dash, can we say the mass of the hanging portion of the chain will be the total mass of the chain by the total length of the chain times the length of the hanging portion? Yes. And the weight of this portion of the chain will be which will be equal to the force that the man has to apply at that particular moment, will be m dash into g, isn't it? Which will be m by L times x into g. Now, knowing that this force is a function of x which is changing with time, we can find out the small work done by the external force, this force F, in the process of shifting the chain up slightly by a distance dx. Let's say this length of the chain goes up by a very small distance dx. In that case, the work done by the person will be f dot dx, which in this case will be m by L times x into g times dx. Yes. Now, since we see that this is a variable expression that we have, we will have to integrate it. We will have to add all these small work dones to get the total work done, and the expression that we shall get will be this. We will have m by L g, which all of which are constants, times x dx, and understand that we want initially, if x was 0, the portion of the chain pulled up was 0. Finally, the portion of the chain pulled up will be L by 3, because it was L by 3 length of the chain which was hanging down. Finally, all that L by 3 will go up. So, the total length being pulled up is L by 3. So, now all we need to do is integrate this function and substitute the limits to get our final answer, which will be, if we take the constants out, mg by L, and integrate x dx, which will give us x squared by 2, and now put the limit 0 to L by 3, we shall get mg by L times L squared by 9 into 2, which is essentially mgl by 18, and this will be our final answer. Now, here in this question we have to integrate to get this answer, because we do not have, in this chapter, work energy power, by this chapter we haven't really studied the concept of center of mass, right? But once you have studied that chapter also, which is the next chapter to this, you will understand that this particular question can be done without using this integration also. So we have another method of going about this question, which is quite simple. So that method goes like this. If we take the chain which is hanging 1/3, L/3 length of the chain is hanging down, right, and 2L/3 is still up on the table. Do you understand that if the man pulls the chain slowly and steadily, just as we have discussed in the same manner, what will be the final effect of the chain being pulled up on the table? The final effect will be that this total chain which was hanging down here, whose center of mass was somewhere here, right in the center of this hanging portion, somewhere here, this center of mass will suffer a displacement of L/6 in the upward direction. Do we understand this? This is the center of mass, which was initially a distance L/6 below the level of the table. Finally, when whole of the chain goes up, this center of mass will reach onto the table, so it will suffer a vertically upward displacement of L/6. And since the chain is being pulled up slowly, we can maybe use the work energy theorem, saying that the work done by the external force on the chain plus the work done by the gravity on the chain, both should be equal to the change in kinetic energy of the chain, which we are assuming to be 0. We are assuming that the chain is being pulled up slowly so that it does not gain any kinetic energy. So in this particular case, we can directly say that the work done by the external force will be negative of the work done by gravity in the process of this chain moving from a position at the center of mass of the chain, moving from a position L/6 below the table level to the level of the table, which in this case will be negative of work done by gravity. Essentially will be m dash into g into h, where m dash is the mass of the hanging portion of the chain, which will be 1/3 of the total mass of the chain, because it is 1/3 of the portion of the chain which is hanging. So it will be m/3 times g times h, the displacement that the center of mass suffers in the process of the chain moving up, which we have already discussed, will be L/6. So see that when we simplify this, it will simply be okay. One more thing, work done by gravity itself will be negative because gravity is acting downward and the chain is moving up, so that will cancel out this minus sign. So effectively we will have a final answer which will be positive, mgl by 18, which is the same answer that we have obtained above. See that here we don't have to do any integration to get our answer once we use the concept of center of mass.